So opposite 30 is x, opposite 60 is, and opposite 90 is. If you do write these today, write these tomorrow, write these Sunday, write these Monday, you got to do it a lot. All right. The other one is our 45, 45, 90. They could give you a 45 or they could mark two equal sides. If these two sides are equal and you have a 90-degree angle, those have to be 45, 45. So those are x, the legs are x, and the hypotenuse is x square root of 2. You will either have a 30 or a 60 in one of these, or well, there should be a right angle in all, or you'll have a 45, or the sides will be marked. So you have to know the difference. We had 2 quizzes on these. So let's go over how we're going to solve these. Okay? Now, there is a video online that you can look at to refresh your memory. If I tell you that P, give me a number,
5.
that P equals 5, you should be able to find ET and PT for me. The first thing you do is draw a diagram. You must draw a diagram. You will label the sides in terms of x as the next thing, and then after that, you're going to take this 5, you're going to put it on the side of PE, and you will write a what? Equation. It is not x. 5 is x squared root of 3, Brittany. Yes. So 5 is not x. You write the equation. The very first number you put on your diagram is your equation and your only equation. So we've got 5 equals x square root of 3. So what do? Divide by square root of 3. Now I'm going to switch sides here. Now when x is equal to 5 over square root of 3, what do you have to do from here? Rationalize. This is an irrational number. So this is going to be 5 square root of 3. What's the square root of 3 times square root of 3? 3. Square root of 9, which is whole number 3. So x is equal to 5 square root of 3 over 3. Now what I've been seeing with people I've worked with before school is all I have seen is this step and then this. Yes, and this is where the problem comes into play. They don't bother to write the equation here. And the importance of this is the fact that there is x and you identify x. As I solve and as I get my answer, what am I linking my answer to? To what? X. The whole idea is that you understand this answer from this equation is x. Now, when I go over to do ET, I see that ET is 2x. What is x? Therefore, I'm going to put it in for x. So that's going to be 2 times 5 square root of 3 over 3. So that would be 10 square root of 3 over 3. We write one equation and one only. After this, it's substitution. Then I go to PT, and I see that it is x. What is x? So we're going to substitute 5 square root of 3 over 3 in for x. And I really can't also emphasize enough to take this ET, to write what it is, then you can see to substitute. PT equals x, and you substitute. The problem is, if you go back to the diagram, you're going to want to set 2x equal to this, and that's going to be an issue. So that's the hardest side I could give you. I most likely have given you one of each. So if we do this again, and I let this be 60, no, I'm going to let this be 60. We'll call this May. May will probably be doing algebra 2 stuff, or at least algebra stuff. This is 30. Opposite 30, opposite 60. X square root of 3, opposite 90. Okay, so this time, what if I tell you that, give me a number.
5.
Not again.
7.
Okay, if I tell you MA is 7, you are going to find MY and you're going to find YA. So the first thing you do is draw your picture, then you label your sides. After all that's done, and only then, do you then say, oh my, on this side I put a 7. What is this? Equals 7. So we're going to come over here and say 2x equals 7. Now what do? Divide by. So x is equal to 7/2. Now we have our x. And so now we're going to come down here. What is my? It's x square root of 3. So we're going to take this 7/2, which is what? And we're going to put it in for x, making it 7/2 square root of 3. Now, what is a y or ya? It's just x. Therefore, we're going to take our x and substitute 7/2. One equation. Everything else is substitution. Okay, do you see how I got x? So now I'm going to come back here and I'm going to see that my is what? X square root of 3. What is x? It is 7/2. So 7/2 replaces that x. 7/2 square root of 3. No, because it's not in a denominator. 7/2 is x, so I put 7/2 in for x, and I've got 7/2. Because I like fractions. I don't like decimals. And I am sure on the EOC you're going to be a lot of fractions. Yes?
If we have it in decimal, will it be wrong?
Well, my biggest issue is that if it's like 10/3, you're going to tell me 10.3, and that's not, that even on the FCAT, that would not have given you credit. That's 10.333 repeating. Now, if you did 10.3 repeating, that would be exact. So I would prefer fractions. Okay, so if it's just like this, it's going to be 7/2 basically times square root of 3 over 1. That's why it's in the numerator and not the denominator. Okay? So when we look at this, what do we want to call this? Let's call it u. All right, that's a u. If I tell you OU, give me a number.
8.
Okay, you're going to find OY and you're going to find YU. So where do we put our 10? We put it on the same side as x square root of 2. This is my what? Equation. So we have x square root of 2 equals 10. Now what? Okay. So x is equal to 10 over the square root of 2. Now what? Rationalize it. 10 square root of 2 over. What's square root of 2 times square root of 2? Square root of 4, which is what? So this is going to be, what happens, what's 10/2? So that's going to be 5 square root of 2. Now that is x, all right? We now know x. So I'm going to come back over here, and I want OY. What's OY? X. What is x? Okay, I need YU. What is YU? And therefore it is? Okay, so this, I think that this is the less complicated one. Less, L-E-S-S, that's 2 S's, not a T. Less complicated. The only way I can make this interesting is to give you the hypotenuse. Now on this one, I can make it interesting twice. I can give you this side, and I can give you this side. Yes, I can give you this side, which doesn't make it very interesting, and I probably will. You probably have one of each of these. All right, your review worksheet is online. It is a worksheet. It's not out of the book. That is your homework. You have a review assignment tonight. And no. So now what we're going to do is these are 6-1 notes, and we're going to summarize the investigation. It says not in the booklet. Well, it is in the booklet. All right. So yesterday, you've discovered that the sum of the measures of n interior angles of an n-gon is n what? Good. Right? N minus 2 times 180. Again, let me reiterate, n is the number of angles slash what? Sides. Because the number of angles and the number of sides you discovered were the what? Same. So I think you could say that this is a lot of arithmetic and algebra. So we're starting with many-sided figures, and then we'll go narrow our focus to quadrilaterals. So the first thing you have to know is what is a dodecagon. N equals 12. It's 2 plus 10. So what's the sum of the interior angles? What's the formula? N minus 2 times 180. All right. I am going to try the name selector. It didn't go well first period. I don't know. I had to restart the computer. It was just going off crazy. So we'll see what happens this period. All right. My recorder is going to be Brian. Okay. So if n is 12, where am I going to put my 12 in my formula, Lucas? So it's going to be 12 take away 2 times 180, which is 10 times 180. Now, this doesn't require special calculators. All right? So what is this going to be, Wendy? It is Wendy. All right. Now, that means that when you add all the angles, it's 1,800 degrees. What's the sum of the angles in a triangle? In a quadrilateral? 360, and it just keeps going up. When you have 12 sides, it's 1,800. So it's nice to have this formula, otherwise you have to memorize them all. And that's not really worth it, is it? No. So now we're, pardon? Yes, you need to know the formula, definitely. Brian, how many sides does a 20gon have? Well, you would laugh. It was a tough question first period. You know, I mean, they never saw a 20gon before. No, that would be a tough one to draw. Madison, what's the formula I'm going to use again to find the sum? I want the formula. Now, if you write the formula on every problem where you have it memorized when you're done, that's an easy way to memorize, all right? So, Madison, where do we put the 20? So we're going to say 20 subtract 2, which is what? 18. All right, so we're going to have someone else. Hopefully you have your calculators out. This goes to Lizzie, who's not prepared.
My calculator said 3,240.
Got a great neighbor. All right, that means, now think about it. When we get to 20 degrees or 20 sides, look how much the angles add up to. That's a lot. Okay. So now, do you remember what a regular polygon is? If not, look at your 6-1 notes from yesterday. What's a regular polygon? Equal sides and equal angles. So now look what this says. And you have to be good readers. Or how about discerning readers is a better word. A discerning reader. We now want the measure of what? One angle. It didn't ask for the sum, it asked for one. But it's a regular what? So what do you know about all the angles? They're equal. And how many angles are there? So there are 8 angles. In order to find the measure of one, do you need to know the measure of the sum? Yes. Yes. All right. So here we go. How do we find that sum? Aaron? Okay, and what's my n? So we're going to have 8 minus 2 times 180. The calculator person this time is going to be Lizzie.
Wait, do you need someone to check it?
Nah.
-3.
Maybe we do. Sorry. Okay. As Lizzie reconfigures, we need a double checker. Samantha?
1080.
Okay. Just when I said we didn't. Yeah. All right. That's all of them. Brian, how do I get down to one of them? So I'm going to take 100 or 1080 divided by 8, Brian. That is 135 degrees. Now, every angle of that octagon is 135 degrees. Your stop signs are regular octagons. They have all equal sides. They have all equal angles. So what's the angle of an octagon? 135. All right, so now how would we do? We only have 2 problems on this. So how do we do a regular decagon? First of all, what does deca mean? Brittany? 10-sided. What formula do we use to find the sum? Times 180. All right, the calculator person's going to be Aaron. We're going to take 10 subtract 2, or 8 times 180. I probably could, but Aaron's doing it, so I don't have to think. Okay, so 1,440 degrees. So now that I have all those angles, and we know they're all equal, Maria Paula, what would that be?
144.
How did you get 144? Okay, do I expect to see that work? If you want credit on your homework test or whatever we happen to be doing. So now notice as the figure gets bigger, the interior angle gets what? And the sum gets, okay. Hopefully I blow your minds away by the end of the period. All right, so that's one way they're going to have you use this. This is another way, and first period did really well with this. All right, so how many sides?
5.
So there are 5 sides. Now, the goal is to find x. If this were a triangle, and I told you this was 10 and this was 30, could you find this? What would you do? 180 because the sum of the inside angles are 180. So, same concept, except it's not 180 now. What do we have to figure out? We have to find the,
3 times 180.
we need the sum of all the angles, correct? We can't do much of anything unless we have the sum of all the angles. So we're going to start there. What's my formula? Lizzie?
Homework test.
Don't tell me. N minus 2 times 180.
Okay, what's my n?
5.
5 minus 2 times 180. 3 times 180. We'll get it. I'll call on someone else. Okay, that's going to be Samantha. You did such a good job last time, Samantha. Can you do that for us again? No, that's all of them. All right. What's wrong with 120? It's not inside. It is outside. What's this relationship? Supplementary. What is this? Look how much you've learned this year. That used to be hard. Okay? So after, you laugh now. It really did used to be hard. I'm not kidding. Mackenzie, what are we going to do now? We want to find x. We know all of them together is 540. Well, if I'm inside a triangle, how do I find this angle? If I know that's 10 and that's 30. So what are you going to do for this figure? And subtract from right. So you've got 90. You might as well do this. You might as well get your calculator going. 98 plus 133 plus 102 plus 60. We're adding those all together, and it is 393. All right. So now that I know what 4 of them are, how do I find the 5th one, Brittany? So I'm going to take, do you see why we had to find 540 first? Because it's, We didn't memorize that. So, Brittany, why don't you go ahead and do the subtraction? 147. So what is x? 147. Now, this one's a little bit more interesting. What do all these arcs mean? Stephanie? They're congruent. So if I let this be x, what is this one? And what is this one? Okay, so how many sides does this figure have, Aaron? So how do I find out how many degrees is in this whole figure? Yep, we're going to do n minus 2 times 180. What's my n? So we're going to say 6 subtract 2 times 180, 4 times 180, and this calculator person will be Maria. Okay, so it's going to be 720. All right, so we've got 720. Now, that is outside. This is different than what we did before. How do I get this inside angle, Madison King? What's the relationship? What do you know about vertical angles? They're congruent. Vertical angles are congruent. So notice I mixed it up a little bit. This is 136. All right. So I need to find each one of the missing angles. This one, and this one. Lizzie, what do you suggest we do? Okay, so we're going to get 396. Then what? So we're going to find out how many degrees are left over for those three angles. What is that? 3? Okay, now, how do does that mean each one of those x's is 324, Maria?
No.
No, what do you do? Why divide by 3? There are 3 x's, so we divide by 324, and we're going to get 108 degrees for each one of those x's. Now, is this a regular polygon? Is it? How do you know this is not regular? Because all the angles are different measures. Exactly. It's a non-regular. Did I say uneven? It's a non-regular polygon. So were those hard? This is the same concept you did for triangles, except you first have to find the sum. All right. So now we want to go here. You know, these are my favorites, right? All right, Erin has a homework pass. How many sides does this figure have? Oh, did she? Okay. So how do we find the sum of all of them? And what is my n? So we're going to have 4 times 180. And when we multiply 4 times 180, what are we going to get, Lizzie? Okay. Now that I know the sum of all of them, what equation do you think we're going to write, Alexandra? What equation am I going to write to find the value of x? We just found the sum of all of them is 720. To x plus 3, x plus 5, plus 3x plus 1, 5x minus 2 equals, right. Combining like terms is going to go to, Albert? is? Exactly. Okay, so now what about my numbers? And that's plus 7 or minus 7? Oh, I did this wrong. First period. Oops. All right, I did negative 7. It's positive 9. All right, Ethan, what do I do now? Subtract 7. So we're going to have 16x, what is that? 113? No, that's 713. Ethan didn't do that, I did that. All right, so now what do we do, Stephanie? Right here. What is that, Stephanie? 0.56? Okay, so that means that that is x. Could you go back and tell me any one of those? How? Oh my gosh, we hardly have any time left. Oh, no, I'm good because I've taught. All right, so this is what we're going to do. Row 1. 3, 4, 5, 6, 8. Row 1, you are triangles. Row 2, you are quadrilaterals. This row, you're quadrilaterals. Pentagons. You are hexagons. You are octagons. Okay, so what you're going to do, listen, what you're going to do is you're going to draw your figure, whatever that may be. That octagon should have 8 sides. It's a stop sign. You're going to draw her. Let's go, hustle. Triangle, quadrilateral, penta, hexa, octa. Okay, after you draw it, I want you to find the sum of all inside angles. No, it doesn't have to be regular. You need to find the sum of all inside angles. How do you do that? We've been doing that. How do you find the sum? N times, right. When you find the sum of all the inside angles, circle it so you can see it later. This is in lieu of the other investigation we're going to do. Okay, now watch. You ready? You are going to extend one side at each vertex. One side at each vertex. You are going to extend one side at each vertex. Extend one side at each vertex. Are you finished with that? Yeah. All right, my question to you is, what is this relationship? Supplementary. What is this relationship? What is this relationship? What is this relationship? And what is this relationship? Okay, so how many supplementary relationships do I have on my picture? And how many sides do I have? So if you've extended one side per vertex, that should work. So now what I want you to do is I want you to find the sum of all the supplementary relationships. Find the sum of all supplementary relationships. How many supplementary relationships do you have, Wendy? Well, count them. Do what I did. It's easier to count them. Well, how many find your supplementary relationships, mark them. It's easier to count them if you mark them. What is this? 1, 2. Well, this is 3. Did you extend this? Okay, so that's 4. That's, and that's. Okay, listen. Shh. Did I ask for one angle of anything? No, I've only asked for what? Sum of all angles inside. Do you divide by anything? No. I want the sum. N minus 2 times 180.
But we already put that right there.
Okay, so now I've asked you for the sum. What does sum mean? Add all supplementary relationships. How many supplementary relationships do I have? 1, 2, 3, 4, 5. So if I have 5 and they're each 180, what's the sum? What do you do?
8 times 180.
Yes. Okay. Do you have your two numbers?
Yeah.
Okay. The next thing you're going to do, listen, the next thing you're going to do is you're going to take the sum of all supplementary, that's your last number. And from that, you're going to subtract the sum of all inside angles. And then that number I want you to highlight. You have a triangle. 1, 2, 3.
That's fine though, because like yours like always have like a line in between. I didn't know.
Do they all equal the same?
This is your supplementary. Yeah.
Oh, okay, that's where.
Okay. Shh. Okay, hold on. Okay. So did you all finish?
Oh. Yeah.
Did you do your subtract? You haven't done your subtraction.
Yeah, right there. 180 minus 108 minus 440.
How did you get 540?
That's
How many
sub-
1, 2, 3, 4, 5, 6.
Yeah, times
Did
one,
you?
times 180 equals 1080. That's the sum of all the supplementary. You said.
Well, then you better go back and find the sum of your inside angles because it's not 540. Yes. Okay. So now this is where I'm going to blow you away. Okay. What did row 1 get? 360. What did row 2 get? 360. What did back row get? 360. What did this row get? What did this row get? Okay. 3 sides, 4 sides, 5 sides, 6 sides, 8 sides. It doesn't matter how many sides are on a triangle. All right? Let's look and see what we've actually found. Hold on. What did we do? We found the sum of all the inside, right? And then we added all these supplementary relationships. When we take away the inside angles, I'm taking this away, I'm taking this away, I'm taking this away, I'm taking this away, and I'm taking this away. So that 360 degrees is the sum of what? This, plus this, plus this, plus this, plus this. So in other words, let me go back. In other words, the sum of now we're going to call these exterior. What does exterior mean? Right, the sum of the exterior angles. Now this is important. 1 per vertex is 360 degrees no matter how many sides. Now, did that work inside? The sum inside kept doing what? It kept growing. The more sides, the higher the sum is inside. But no matter how many sides we have, what will the exterior angles always measure? 360. So what this is going to do is this is going to allow us, given an angle measure of a regular polygon, to determine the number of sides, because 360 is always constant. Okay? So that's going to be where I'm going to pick up on Wednesday. So I will probably adjust Monday's assignment to cover just the inside angles that we've done.
What notes are these?
6-1.
It's not our homework, it's just easier.
833 is your review. It's a review worksheet. Your test this time is 9.